How's everybody doing?
Thanks, guys.
Awesome. We're gonna nerd out about robots here. Might be the most informal chat you've had today, but it'll just be three robot guys up here talking about robots and why that's important and how that relates to you. So we're gonna keep it fairly high level, medium level, and maybe if you want to grab us after and get into the nitty gritty, we can.
Me too.
But my name's Ethan Blagg, founder of Nexus, working to make robotics more accessible. So building software and hardware, building an operating system, and building modularly configurable drones for commercial application. And then we've got Ian here.
Yeah, Ian Musius, co-founder and CTO of Firestorm. We're building 3D printed fixed wing UAS mostly, also building the distributed manufacturing or expeditionary manufacturing method to build those near the point of need at the edge, and a bunch of other fun stuff. But yeah, excited to be here today.
We got Kai all the way from Finland. Pretty amazing.
Fair enough. So I'm Kai Backman, co-founder and CEO of Manifold. So I come from a software background. So I used to work a lot with distributed systems and that type of stuff. And we're specifically tackling intent capture for robots. So the idea that we float around is that tradesmen in the future won't necessarily in the short term be replaced by robots, but tradesmen using robots will definitely replace tradesmen not using robots. So the question we're trying to answer is that if you have somebody who's not necessarily familiar with robots or familiar with computers, but they know something really well, how can they use this new technology to go forward? So deep tech background, but very kind of practical problem to trying to solve.
So the format we're going to go with, we'll cover a brief background of robotics, what's led up today. And I think there's some sort of shift happening in robotics where they're much more accessible and more people can use them in their everyday life or build businesses with them. So we'll explore that shift and looking forward of kind of what the next steps are, what are the bottlenecks need to be addressed, and hopefully a magical Jetson type world that we can live in the future. So I think I'll kick it off with robotics as a whole, the last 50, 60 years, has largely been in academia. It's been in research labs, 10 to 20 year time horizon research projects. That's kind of built the necessary foundation that we have today, but there wasn't much commercial focus with those projects. So the shift that we're in now is hardware has become accessible enough, software has become somewhat simple enough that normal people can start building businesses and solving real world problems. Obviously, there's quite a bit of defense application there as well, reducing the cost and flexibility there. But I think it's a really exciting time that we're in with robotics where, the common man is being able to get their hands on the stuff and go do cool things with it. But do you guys have any input there? Maybe like history of robotics, interesting points, perspectives that you have on what's led us up today and why that's important and how things are changing?
Yeah, I mean, I can take a crack at it, I guess. In college, I remember maybe dating myself a little bit, but you'd get your Roomba dev kit, and that was like the first robot, at least like ground-based, that I remember programming and having to do things. And to see just, now 15 years or so, coming around to where now it's, drone dev kits, it's fixed wing, multi-copter, there are, Spot, all of these things exist out there that didn't exist, 15 years ago, at least in an accessible format. And so just to see the evolutions there, that folks can get their hands on easily, how that lends itself to STEM, how the sort of like flywheel effect that we're going to see in academia, starting from younger and younger folks getting their hands on everything from, like my specialty, 3D printers and the access to that and how now available they are. And we're kind of coming to the vision that a lot of folks had early on in 3D printing of 3D printers almost definitely in every classroom, sometimes in every kid's bedroom as well, right? And so that access to not only build robots, right, easily, but then program them, use them for different tasks, whether that's around the house for all kinds of cool things like we heard on the last panel, or whether that's for defense purposes. You are going to see this wild adoption of this technology continue to kind of snowball. And I think what I'm most excited about is all of these founders or to be founders that harness this technology for all of these problems that need to be solved. In our world, we're solving them for military applications, but it's a whack-a-mole of how many applications need to be solved by robots, and we're going to continue to see people who harness that in their own unique ways. And I just hope that that continues at such a wild clip that we're seeing right now.
What do you think have been the major changes or breakthroughs that have made that possible? Is it hardware? Is it software? Is it compute? Like, what would you say has changed fundamentally that more people have access to robotics now?
I mean, right? Like robotics have got a lot more intelligent, and the access to be able to program them, the access to compute, the costs have all come down wildly, and so now you do have this availability. I mean, I think that's the big thing is, you now don't have to be necessarily a software engineer to interact with a robot. We have dev kits for that. We have, maybe not quite no code yet, but I think very soon some of that. But yeah, you can interact with this system so much easier. So it's bringing down the barriers to entry, and that obviously allows more people to get involved. And I do think it is a cost problem that's come down, multiple factors in the last even 5 years. But certainly over 20 years, we've seen it go from something that, labs, universities, et cetera, are doing to now, young kids can pick up and cost effectively access this, which is, it takes an investment in industry. It takes really a whole kind of world awakening to it, and we've really had that over the last 5 years or so.
I think there's so I've mostly been founding companies in my life, but also spent a few years on the VC side. And one of the things that people don't understand kind of inherently is exponential functions. So like everything in our world is kind of linear. We expect people to be a certain length, and we don't expect to see like 12-foot people walking around the Earth. But when you look at this exponential development, which the robotics clearly is one, things look like nothing happens for years on end. So in venture investing, often the ideas that are the investments are the best is an idea that was really bad yesterday, but today turns out to be good. And many times it's like the gradient, the actual step might be time. Like, there's a lot of good reasons. Like, yeah, we have more access to electronics, more access to printing, more access to these things. But I think the bigger pattern is that once you do break out and you kind of start getting the acceleration, you get the hockey stick that all the VCs love. Like, 10 years, 20 years, this was a dumb idea. And then suddenly 3 years from now, everybody is like, what do you mean robots? Like, why are robots a thing? They're everywhere. Like, why are we talking about them? Like, things become so common, so kind of mundane that we no longer pay attention to it. And those kind of, I think the next 3 to 5 years are going to be wild in the sense that we're going to probably from this, like, be sitting here and thinking about, oh, wow, this stuff is really cool, to the point where nobody's going to pay attention to the thing because it's like everywhere in society. So like, yeah, the reasons are fine, but I think the bigger kind of, for me at least, the takeaway is that now is a great time to be around these things because clearly a lot of stuff happening. Let the historians figure out what exactly was the thing that drove it.
What do you guys see right now in robotics are the biggest bottlenecks to having widely adopted implementation of robotics? What's the bottleneck?
I don't know that there necessarily is a bottleneck right now. I think we're maybe past that point. I think we're kind of getting close to where it is mundane, and I think that's an amazing point to be in history. Like to be alive when, hopping in an airplane later today or whatever is just, like a walk in the park and you don't even think about it is pretty cool. We're living through a time in history of many more of those types of things becoming entirely mundane. And I think, in robotics, I think we're a little bit past, or we're I guess on the slope of enlightenment on the Gartner hype curve is where I'd say we are. And that's a fun time to be alive. So I do think, there will be, again, even more access, less barriers to entry, all of those things. But I think we're kind of past that more or less. And now it just becomes how much simpler can we make it to adopt? And to your point, it's like that is where we see exponential growth, and we're in that phase, I would say right now.
I think there's other framework you can kind of take a look at it, and that's usually when these disruptions happen, the distribution is very uneven. So people kind of expect like this steady march of progress. I mean, we expect it in sciences, we expect it everywhere, like progress kind of marches like a front of First World War, like kind of armies going over the field. But in reality, what tends to happen in both science and especially through these disruptions is that there's like a super spiky. If you actually zoom in, things are very, very spiky. So you're gonna see domains where robotics is like yesterday's news, that where they're really applicable, they're really easy to do. And then some things people expected to have earlier is not gonna happen. So, 10 years on, we're gonna have that broad front again and we're gonna look at it. But I think right now, the interesting thing is looking around and going like, okay, this application happens today. That application might take 2 years to happen, and that application is probably 5 years out. So the interesting thing is like bottlenecks. There are some things that are kind of will be really hard for many years to come, and there's not much we can do about it. Whereas like there's some things that are already today are absolute game changers with the stuff we have today. So I think thinking about it more of like going in and looking at it at a granular level, looking at kind of individual robots, capabilities, problems, markets, what do you have, that's going to be interesting. Like you're going to find things where the future is happening today. And then there's some things where, you just can't make it a lot faster. You will have to wait for a few years for it to happen. So, I mean, again, there's like the macro versus the kind of individual actionability. For most of us, we're actually interested in what we can do in this world, as opposed to kind of looking at the broad things. I mean, like I say, most of those big bottlenecks, they're beyond my pay grade. So what I do is like focus on the small things that we can do and we can actually push forward. So I think this granularity or this spikiness of progress is super good. They're literally individual people, individual companies, individual friendships formed amongst like competitors, for example, that push the state of the art forward. And there we see crazy progress going on.
Really seems like there's a bottoms-up movement happening where you have common people, engineers, blue-collar workers, entrepreneurs that are finding these very specific problems that they know a whole lot about, and that it would mean the world to them if they could solve it. And for some reason or another, the light bulb switches on like, oh, a robot would actually be the best way I can solve this particular problem. And they venture to figure that out and build it themselves. And I think that's something that's very special. It's a shift that's happened maybe within the last 5 to 10 years, max. And I think that's something we can help accelerate and support. So reducing that barrier point of entry to robotics, shortening the time it takes to deploy robotics, and time it takes to build them as well. So it's an exciting time to be building a robotics company, but also exciting time for you guys of having access to this new technology. It's actually practical, actually useful in your day-to-day life. And there's so many different problems you can solve with these things. I know you and I were doing drones, so I'm kind of biased towards that. You have people using drones to power wash the side of buildings. It's a big tethered drone. You're using drones to knock ice out of power lines. And these are guys that, formerly were working on an oil rig, and now they figured out they can fly drones and they're making 80, 90 grand a month out of their truck flying drones around. It's amazing. I love this future. It's wonderful. I think maybe one elephant in the room we could talk about is China and manufacturing. So I know DJI has obviously pioneered, the drone industry. At one point, they had an 80% global market share on drones. Pretty incredible. They do have some amazing technology. The United States is trying to catch up with production capacity and manufacturing. I'm curious from your perspective what your thoughts are on that.
Yeah, there's all this talk of of the Apple of the drone industry, and it exists. It's DJI. Like there's these upstarts that maybe want to say that they're the Apple of the drone industry or try to move into that direction, but they exist, right? And so they've gobbled up market share. It's a great product, but we have a problem, right? A political, let's call it, plus economic adversary of ours owns 80% of the market share in multicopters. Not good for us, and right, and that we've shot ourselves in the foot as a country in that space a lot. I think we're starting to turn a really big ship, which is to say we need to make these component. I'm talking at the component level all the way up to the drones. in our country. Things like DIU's Blue UAS list. We're moving in the right direction, but we have to work together is one of the problems. I think we're trying to see it as like maybe we're going after that 20% market share, and we have all these upstarts and startups kind of competing for that. I think we really have to look at partnering. We have to look at standardizing a lot of our components to start to bring a lot of that manufacturing home. And if we truly are worried, which we should be, about what code is hiding on these aerial vehicles that our military in some cases still use, they're not supposed to, but guys are going to use, especially operators, right? They're going to use what works, and sometimes that's putting something on a charge card and getting an aircraft that works. So I think we have to build more here. Obviously, doesn't even need to be said. But we have to partner with each other to make sure that we're not competing, just in the U.S. or with our European allies to build. We have to, we have to look at who the real competitor in the room is and understand that there's a vast amount of market share to be had. But really look at it from a ground-up level of building more U.S.-based organic supply chain. Working with those folks, not trying to compete with them, but partnering with them, giving them money, helping them be your next best partner. And then really kind of bringing everyone in under the tent, quote unquote, to make sure that we can deliver the amount of stuff that we need to deliver. I mean, when China can put in an order to a single manufacturer of 1 million loitering munitions, and we couldn't build that with all of the drone industry that exists in the US, we have a big freaking problem, and it needs to be solved very quickly.
I think there's kind of this is a tricky take, obviously, because it's a very big question, mind you. Like my way of thinking of it has been, I think there's like 3 levels of kind of, nowadays everybody agrees that the US manufacturing base is a lot lighter than it should be. So there's like common ground there, which is a great start. I think there's kind of 3, to my view, there's like 3 kind of levels of awareness. The first one is basically that let's copy it. Like, let's build the same thing that China has built. I think the second set of people are like, okay, that's a great idea, but it turns out that like the thing China did to catch up with the US is actually something that the US probably can't do again. Like there's a lot of kind of dependencies on how that happened, and it doesn't look very realistic. There's a lot of people yesterday who were talking, for example, who are in the second group. They're basically saying like, we're not going to be able to catch up. At least we're not going to be able to copy what China has. So what do we do? And I think the third group is basically like, having gone through all of that, is that the realistic option is, the problem with copying is that you're trying to, run after a moving target. So you do something, China already has a really, really good ecosystem. You copy that, well, they've been developing while you copy it, so it doesn't work. So we do see in technology, and if you look like a long history of time, we see these things where like, you see leapfrogs in technology. So the key to a leapfrog is that you need to do something where your opponent, in this case China, doesn't like have a strength. You need to basically you need to work with their strengths. You need to do something where if they did that, that would actually weaken them. So Achilles' heel is the classic thing that people talk about. And everybody's, okay, it's like, why did he have the pesky heel? I mean, he was, invulnerable otherwise, but then he had the heel going on. But the key to remember is that the heel is where his mother held on to him as she dipped him in the sticks to make him invulnerable. So if Achilles hadn't had the heel, he wouldn't have been Achilles in the first place. So I think with the leapfrog, I don't quite know what it is, but I'm starting to see kind of, there's some places where we have a bit of that. So Starlink just had a video a few days ago about their factory east of Austin. And they basically, like in one end, they're taking in aluminum ingots and plastic pebbles, and in the other end, you have Starlinks popping out. So China is a deep network of suppliers. So whatever you want, you can basically have a supplier come up with the thing. It might be that we have one chance to leapfrog, is to have these end-to-end factories that take in very low-level raw material. And actually, as the speakers were in the previous panel saying, the more they insourced into the company, the better, the faster they were able to move. So maybe the leapfrog is something like that, a cohesive kind of in-house production line where we take in a lot lower grade raw materials, but that means that we can the thing with the Starlink experience, maybe places like Anduril as well, is that when you own so much of the chain and you have a flexible manufacturing chain, a lot of robotics, people who are really good at kind of doing process changes, and you think about it from beginning to end, that's something that China is not specialized at. They're not as good at that thing. That might be one way for us to if we build up that capability in the US, that might be one way for us to leapfrog China as something uniquely competitive, because in the long run, that looks like if you could build factories like that, that looks like actually a lot more powerful than the supplier network. You're more resilient to supply chain shocks. You're more resilient to design changes. You can change your design and change your manufacturing faster. So I think looking at it, leapfrogging has happened many times. We leapfrogged China as Western civilization like a bunch of years ago. So this is certainly a possibility. But I think that to me is like the optimistic scenario. Like you look at what we can actually do here that's different. Instead of just copying, could we start playing towards the really interesting target in the end? And I think this is also something that's really aligned with US mentality, like the US entrepreneurship, like the US kind of way of thinking. I spent quite a bit of time, a decade or more in the US kind of building enterprises. This is a great place. Like the thinking here is very unique. If we can harness that in the way we think about the manufacturing, that probably is the way that we can do something that kind of gets ahead of the curve with China. So
Let's dream for a bit here. So looking forward with robotics and drones, what are you most excited about? Where do you hope things end up? What is that ideal future circa robotics are fully implemented? What does that look like for you?
Yeah, I mean, we're really excited about standardization, which sounds kind of funny, but standardization is going to be the key here. I know you're working on this as well. We leverage a lot from open source, so open source standards, open source protocols. Our autopilot is built off PX4, which is an open source autopilot. Our ground control software is built off QGC, which is an open source control software, and then the Mavlink messaging protocol, how we send messages back and forth to our aircraft, open as well. And so in openness, there becomes sort of standardization or pseudo standardization as long as there's folks adopting that. Many folks are adopting it right now, which is exciting. The second thing that I think I'm excited about there is what are all the future standards that are going to kind of come out, and not to be additive like our conversation earlier, but like what are we really going to adopt in our world on the military DoD level? We have things like mod payload compliance. It was nice SOCOM pushed it. It actually is pretty performant, and I think we will leverage it as an option, but it doesn't have quite the adoption that we would want to see, right? Where everyone is building payloads that are all mod payload compliant. That's kind of the future. Now we want something like that to exist. I think it will be willed into existence by everyone needing to have interoperability, which is kind of another big word out there, right? I think when we truly have that interoperability across a bunch of different, both UAS OEMs, but also just component level, subsystem level suppliers, we all help each other out. Like if we can adopt those things, and really where the proprietary nature of stuff is not in some of these low level, controls and communications protocols. Like that's not really where the proprietary nature of what you're building lies. You can adopt all of those things and still have a bunch of cool proprietary IP around it. But if we can, I'll say it a lot, like we have a partner in integrate first ethos. That means like we don't want to make it if it's already made and is made well enough and our customers will adopt it. And I think that's just what our industry needs. It's like we cannot manufacture enough stateside right now to meet our needs. So we have to partner and we have to grow together and we have to support each other. And in that, the interoperability, I think, will kind of organically grow and be fostered. So I think that's what I'm excited about. I'm excited about less kind of like competition over the crumbs and more trying to go after the big pie that exists on the global stage.
So more so spending your time and energy and resources on the actual application and not all the bits and parts and pizzas. We had a prior conversation. The robotics industry scales much better if you have the really smart MIT Carnegie Mellon folks that are able to specialize on the thing they do really, really well. Maybe it's navigation, maybe it's collision avoidance, maybe it's sensing. But when they're having to build full stack just to be able to compete with all these bespoke systems, it's very, very slow to grow the industry. But if you're able to compartmentalize things, allow people to really jam out on what they do best, we can put all those pieces together. Not only works if there's a decently high degree of interoperability and standardization. So I'm very excited about that as well.
I mean, the other thing too is there's going to be commoditization in this industry like we've never seen before, right? I mean, like if everyone's just using the same perception algorithm and then trying to, give you, SLAM or other like vision-based navigation products, that there's going to be saturation there. Like I'm already seeing it, right? I talked to no knock on anyone who's building vision-based navigation, but it's like there's a new one every week that I'm talking to that wants to integrate with us, and that's great. But that also shows you that the barriers to entry of building, robotic perception are not as high as they once were. So that's amazing. But it also means that companies need to be careful about where they want to invest their time, effort, et cetera. Like what do they want to exploit in the industry right now? Take advantage of, and is that something that will be commoditized, or is that something that exists using a commoditized piece of technology to benefit whatever their other greater thing is?
It's like what I'm excited about, or the drone specific thing. I actually want to talk something about which I think is interesting, kind of related to the drone bits. So I've been super kind of, we all know about the humanoid stuff that has been kind of popping out. There's a lot of cool demos and so forth. So I've been trying to kind of segueing a bit from this topic, but I've been trying to figure out what the form factors would be that we go forward. So it took me a while to understand why the humanoids kind of made sense, because it seemed like an exceedingly hard form factor to pull off with legs and stuff. But if you think about it from the kind of user standpoint, there's a lot of stuff in the world that we built for humans. I mean, most of us spend 90% of our time in an environment where like everything is built for humans. So that seems like actually a very sensible form factor to have. I mean, my bet is that you probably see actually on the drone side a lot, is that we're gonna have like a bimodal world where we have a bunch of like very human-like form factors, which are basically fit into all the environments that the humans have. Maybe they have wheels, maybe they have legs, but actual humanoids. And then we're gonna have a Cambrian explosion of like all kinds of stuff, like maybe a lot of biomimicry, but also all kinds of like funky things, spider legs pulled together with random arms, because that makes total sense. So like it's going to be interesting to see where the like your kind of comment about the commoditization is that in some ways I think the humanoid side might become a commodity faster. Like they're going to hit some sweet spot where it's kind of done. Like it's going to become more efficient, but it more or less it fits into the human world and it's good. But I think on the Cambrian explosion side, oh man, it's going to be interesting to see what comes out of there. Like, I mean, we already see all these fancy drones. Obviously in the Ukraine, we have the drones that are on fiber, but I also seen a lot of drones that are on like tethers. And like, first it doesn't make sense, but actually, yeah, you could have something that has a bunch of tethers on it, which means that you don't need to think about power consumption because you have a huge battery sitting down. So like, I don't know, that it looks like that side is going to be a lot more churny than the humanoid side, which seems like it's kind of peter out maybe in a few years.
Yeah. I'm sure we could nerd out all day. Sure, we've talked your ear off here, but thank you guys for your attention. Do we do a Q&A? Do we cut it off here? Yeah, cool. I think we're out of time. You guys are probably hungry and ready to go home anyway. So thank you all for your attention. Thank you for your time.